Today we're going to look at linear regression. Our learning goals for today's lesson, and we're going to be able to draw a line of best fit for a scatter plot, use a line of best fit to interpolate and extrapolate data, determine the equation of a line of best fit as well. Linear regression is really very important for a lot of science applications, and you'll definitely be required to do it in senior physics. You'll definitely be required to do it in other in Maths B and in other subjects. It's one of the most common types of operations you're required to perform with data to try and be able to develop a line of best fit and then get an equation from that line. That equation then allows you to make predictions about other events inside of your data range and also outside of your data range. So it's a very, very powerful form of being able to make predictions about data and about how it might change in the future. You can also use a number of different programs to allow you to perform regression analysis, including Excel and MATLAB as well. So we'll be able to go through some of those in class. So firstly, a line of best fit or trend line is positioned by eye by balancing the numbers above the line with the number of points below the line. And often in this, you'll try and disregard any outliers that you might see in your data set. So it's best to use a clear ruler when trying to do it by eye, because then you can make adjustments and position the line as best to try and balance the trend of the data as it's increasing or decreasing. The line of best fit can be used to find an unknown point within the given data range. That's called interpolation. So inter means inside. So interpolation allows us to find a data point within the data set that we have, or we can extend it outside of the data set that we have to extrapolate. Extra means in addition to, outside of. So we can look outside of the data range by using extrapolation. When we find an equation of a trend line, it's called linear regression. Okay, so to regress means to move backwards. So it's us working backwards from having the data to determine a linear trend line. So these are the steps that we need to perform a linear regression on a scatter plot. We draw our trend line first by hand, by eye, trying to balance those points. Identify 2 points on the line. This is very, very important. They need to be on the line, otherwise they're not going to be they're not going to describe that trend. If you use some of the data points that are off the line, then it's not going to work. Sometimes you might need to just choose any 2 random points on the line that aren't actual data points to be able to find the equation of the line accurately. It's very important to do that. Use the 2 points then to determine the gradient of the line, and then use y equals mx plus c to substitute one of the points on the line to actually determine the equation to find the value of c. So let's have a look at an example now. This example looks at a relationship between an English mark and a literature mark for a small group of students. So the first question that we're asked to determine the equation of the line using linear regression. The first step is for us to draw our line of best fit. So here we go, draw our line of best fit. There we go, nice and neat from me for once. And our second step now is to determine 2 points that are on the line. I can see there's 1 point here that's very clearly on the line, and 1 point here that's also very clearly on the line. So we can use those 2 points. So those 2 points are 40 for the English mark and 30 for the literature mark. And our second point is 60 for the English mark, 60 for the literature mark. There. So let's determine the gradient. So gradient is rise over run. Our rise over run. So our rise is from 30 to 60. So our rise is going to be 30, and our run is from 40 to 60, so 20. So then that reduced down means we get 3 over 2 as our gradient. So if we've got y equals mx plus c, then, and we can substitute one of our points in. I'm going to use the first point here, the y value being 30 is equal to our gradient of 3 over 2 times the x value of 40 plus c. So we can reduce this down. This is going to be 30 is equal to, let's see, 60 plus c. Subtract 60 from both sides, and we get that c is going to be equal to negative 30. So that means our equation for our graph is y is equal to 3 over 2x minus 30. So we've performed our linear regression on our line now. Performed our linear regression and we've determined the equation of our line. We have linked the x and y values, and if we substitute in values now, we should be able to determine the different scores for different or the different corresponding scores if we know the English mark or the literature mark. So let's do that now. I'll just erase some of this so we can read it clearly, but keep the equation there to remind us. So now we're being asked to use the equation to estimate a literature score if the English score is 86. So the English score was on our x-axis, so x is our English and y was our literature mark. So we know our formula, y equals 3 over 2x minus 30. The English score is 86, that means our x value is 86, so we can substitute that in. Y equals 3 on 2 multiplied by 86 minus 30. So if we plug that into our calculator, we get that our literature score is 99. So we can say, therefore, the literature score of a student receiving an English score of 86 is 99. Now obviously we can see a little bit of a limitation with this particular equation. If I start going much above an English score of 86, which is possible, it's possible to achieve more than 86 in English, then the percentage that I'm going to get for literature is going to go above 100%. Is that possible? It's not really possible to get more than 100% for an exam. So we can see that there is a limitation to the results here. We're obviously not going to be able to get more than 100% on our literature exam. A key limitation to kind of consider. Let's have a look now at the part, so that was part B, that was the answer to part B. Let's have a look now to our answer and try and find a solution to part C. So part C is asking us to use our equation to estimate the English score if the literature score is 42. So we've got our formula here, y equals 3 over 2x minus 30. If our English score, our literature score is 42, that means our y value is 42. 42 is going to equal 3 over 2, x minus 30. So in order to solve this, we need to get x by itself, so we need to do some algebra here. Adding 30 to both sides, we get 72 is equal to 3 over 2x. And then we can get x by dividing both sides by 3 over 2. So 72 divided by 3 over 2, or multiplying by 2 over 3, it's the same. And we get that the English score should be about 48. So we can say, therefore, the English score for a 42% literature score should be 48%, sorry. And that's how we can use our line of best fit, our linear regression formula, to determine some unknown values for our relationship. We can also kind of think about the limitations of these linear relationships. Sometimes other relationships might be helpful, but sometimes we need to set boundaries on those relationships and say they only apply between these values. So just recapping on our learning goals for today, we've looked at how to use linear regression to determine an equation of a set of data by putting a line of best fit through our data by eye and determining the equation of that line.